Hey guys, welcome to Unit 10, Lesson 1. Our topic today is the mean value theorem. So let's get started with the warm-up. It's given to us a function f of x equals x squared minus 9 over 3x, and it's asking us to graph f of x over this interval 1 to 4. So all I'm going to do is take the values, and 1 and 4 are included. So substitute 1 into the equation, so I will get negative 8 over 3 here. If I substitute in 2, I get negative 5, 6. 3, I get 0. And 4, I get 7 twelfths, right? So I'm going to take this and I'm going to graph this over here. So negative 8 thirds is a little bit more than negative 2 halves. So it's going to be 1 and negative 2 halves, which is like over here. Then I have 2, negative 5, 6, a little bit less than negative 1. So 2, that's like a point here. And then I have 3, 0, and 7 twelfths, a bit more than half. So 4 and 7 twelfths is here, right? So this is what my curve looks like. Okay, so now it's asking us find the average rate of change of f over the interval 1 to 4. So the average rate of change is what? It's basically the slope of your secant line, right? Let's write that down, slope of your secant line. And how do we find average rate of change? It is f of 4 minus f of 1 over 4 minus 1. So f of 4 is, I already know, it's 7 twelfths minus negative 8 thirds over 3, right? This would be what? 7 twelfths plus 8 thirds, it would be 39 over 12. And then if I do keep change flip, times 1/3. And if I simplify it, 3 goes into 39 13 times, 13 over 12. Yes, so now part C says find the instantaneous rate of change at x equals 2. So we want to find the instantaneous rate, which is the slope of the tangent line. This is your slope of tangent line we need to understand, or my first derivative, right? So we want to find the first derivative evaluated at 2. Either I can actually simplify it, I can rewrite this up here. I'm going to just rewrite it as x squared over 3x minus 9 over 3x, which will make it simpler to take the derivative, which is same thing as x over 3 minus 3 over x, right? Or I can rewrite it as x over 3 minus 3x to the negative 1 power. So it'll be easier to take the derivative and evaluate it at 2. So f prime of x will be, so derivative of x over 3 will be just 1 over 3 plus derivative of negative 3x to the negative 1 would be positive 3x to the negative 2. So I'm going to evaluate it, which would be same thing as 1 over 3 plus 3 over x squared. So let's evaluate it. It would be f prime of 2 is 1 over 3 plus 3 over 2 square is 4. You simplify that and you end up with 13 over 12. So what did you notice? You notice that the answers in part B and C both are the same. We're getting the same slope for our tangent line as well as the slope of the secant line. So that's what we noticed. So let's write that down. Slope of the tangent line, the secant line, is equal to slope of tangent line. And that's a special case, and we are going to tangent line. That's a special case, and we are going to discuss more about this. So let's get started. So we are talking about the mean value theorem. That is, the mean value theorem actually connects the average rate of change of a function over an interval to the instantaneous rate of change of the function at a point within the same interval. So copy those notes for guys. And what does the theorem states? The theorem states that if f of x is continuous at every point on the closed interval AB and differentiable at every point on the open interval AB, then there is at least one point C in AB at which f prime of C is equal to f of B minus f of A over B minus A. What is it basically saying? That if your function, given function, is continuous on the closed interval, remember this is a closed interval, and differentiable over the open interval, only if these two criteria are true, then your instantaneous rate of change will be equal to your average rate of change. That's the whole idea behind these questions. So we have to, our goal is to actually find a C that makes our rates same. That's what we're going to be doing. Okay, so how do we get started with these examples? Let's get started with the first one. The first one says find all values of C that satisfies the conclusion of the mean value theorem for f of x equals square root of 2 minus x on the interval from -7 to 2. So the first thing you always need to ask is, do f of x satisfy the conditions for MVT? And those were two conditions. The first one is to check if it is continuous. So if I want to check it's continuous, if I substitute any number start from -7 between -7 and 2, does it make my function, like, do I get a negative under the radical, an imaginary number, or something undefined? I don't. So it is continuous, right? You can check for any values, you can and see, but it does not. So just want to write continuous. So it is continuous over this closed interval. So -7 and 2 are included, right? Even if I substitute -7, I get 2 minus -7, which is 2, plus 7, which is 9. Square root of 9 is 3. If I substitute in 2, 2 minus 2 is 0, and square root of 0 is just 0. So I do not end up with a negative number. So this is good. Part 2 is I need to check if it's differentiable over not a closed interval, over open interval. Please be very careful, okay? Over 7, 2. For that, I need to find my derivative, right? So let's find the derivative of it. So f prime of x is what? This would be, I can rewrite this as 2 minus x to the 1/2 power, 2 minus x to the 1/2 power, and I'm going to use my chain rule here. So this would be 1/2 2 minus x to the -1/2 times -1, right? So if I simplify this, I get what? -1 over 2 times square root of 2 minus x. So if I pick any numbers between 7 and 2, not including 7 and 2, right? So is it differentiable? Yes, it is differentiable. So be very careful. 2 is not included, because if you checked for 2, you'll be like, oh, I get a denominator of 0, so it's not differentiable. But we always said it's an open interval, so I'm stressing over it over and over again. Okay, so it does satisfy the criteria or the conditions for mean value theorem. So now I need to find my C. As per definition, what is it? I want to find the C where my instantaneous rate of change is same as my average rate of change. So f of b minus f of a over b minus a. So what is my derivative of my function is -1. Just gonna switch colors. -1 over 2. You can choose to keep x or use the same letter as c. It doesn't really matter. And f of b. So if I substitute in b, I have to substitute into my original function. So it'll be f of what? b is 2 minus f of -7 over 2 minus -7. If I substitute in 2, I get 0. And if I substitute in -7, I get 3, right? Over 2 plus 7 is 9. And over here, I get 2 minus x. So Let's simplify this. I get the right side is negative 1 over 3 and the left side is negative 1 over 2 rad 2 minus x. I can call this x or c. We talked about this. It doesn't really matter that way. If you feel more comfortable writing c, please write c. Okay, so I want to solve for c. I'm going to do it here. I'm going to cross multiply and I'm going to, my negatives cancel out. I have 2 rad 2 minus x. So it's 3 over 2 equals 2 minus x. Square both sides. I get 9 over 4 equals 2 minus x. And I get x is equal to, negative x is equal to, I'll subtract 2. And that would be 1/4, right? And x will be equal to negative 1/4, or x or c. So I did get c equal to be 1/4, and you have to check, is this number negative 1/4 in that interval? Yes, it is. It's in this interval. So the idea was we have to find a value for of our first derivative evaluated at negative 1/4. So basically we are trying to evaluate at a value where our average rate of change is same as the first derivative. So can we do the same thing to find a value of c that satisfies the MVT for f of x on the interval from negative 5 to 4? Explain your reasoning. So in order to apply MVT, we need to check if it is continuous, and if it over this interval negative 5 to 4, closed interval negative 5 to 4. And second, I need to check if it's differentiable over open interval of negative 5 to 4. So let's check for our continuity. So if I substitute in 4 in my function, which would be what? We get a negative number under the net radical. We'll get square root of negative 2. So it is an imaginary number, therefore it is not continuous. So if it's not continuous, we don't even have to check for other things, right? So can we do the same thing? No, there is. So let's write this down. No, because f of x is not continuous at x equals 4. So basically that's what it is. So we're going to do another theorem, which is the Rolle's theorem, which is an extension of the mean value theorem. I don't think it is a different theorem, and you'll see it why it's not anything different. It's a little extension of that. What it says is, if f of x is continuous at every point on closed interval ab and differentiable at every point on the open interval ab, and f of a equals f of b, then there is at least one value of c where f prime of c is equal to 0, or the first derivative of c is equal to 0. And that's true because if f of a is equal to f of b, think about it. What do I have? My average rate of change is what? F of b minus f of a. But since f of b and f of a are same, wouldn't they cancel each other out? They'll cancel each other out, and that would be equal to 0. So that's why I said it is an extension of your mean value theorem, the Rolle's theorem. So let's try example 2. It says, find all values of c that satisfies the conclusion of Rolle's theorem for y equals negative x squared plus 8x minus 17 on a closed interval of 2, 6. So again, same as your mean value theorem, you always check for the two criteria or two conditions. The first thing is to check for continuous. Is it continuous over this closed interval 2, 6? And I need to check if it is differentiable over the open interval 2, 6. So for continuity, I'm just going to start substituting in numbers from 2 to 6 and see if it's continuous. It's a polynomial, so it's going to be continuous everywhere. So it is continuous, right? To check for differentiability, I need to find my first derivative. So if I do y prime is equal to negative 2x plus 8, which is also continuous all along, so it is differentiable over this interval. So now, in order for Rolle's theorem to satisfy, basically what I'm trying to do is I'm going to find my, say my instantaneous rate of change is same as my average rate of change, right? You can choose to actually find your f of b, which in this case would be f of 6, and f of a, which in this case would be f of 2. If you get the same answer, same, you know it's going to be Rolle's theorem. Rolle's theorem. Then you can literally set this whole thing equal to 0 and just solve for that c, right? Or if you forgot to do that, you can just start from here. You can do negative 2x plus 8, or if you can choose to write negative 2c plus 8. And f of b, if you substitute in, which would be actually f of 6 minus f of 2 over 6 minus 2. So let's do this. So plus 8 equals f of 6. If I substitute in 6, I get negative 5 here. And if I substitute in 2 into my original function, okay guys? So I do end up with negative 5. So what is negative 5 plus 5, which is what? 0. This gives me 0. So basically, either you could have done this whole thing on the side, or I can just write negative 2x plus 8 equals 0. If I want to solve for x, I get x equals 4, right? And x equals 4 is in the interval of 2 comma 6. If you want to write c or x equals 4, it's the same thing. Okay, I want to actually try do 2 more questions with you too. So it says, for the practice problem, for each of the problem, determine if it's the mean value theorem or Rolle's theorem. Remember, how do I know, how is Rolle's theorem different from mean value theorem? When f of a is equal to f of b. If that's true, then it's Rolle's theorem. If it is not true, then it is mean value theorem, as long as they both are continuous and differentiable. If it can find all values of c, that satisfies the theorem. If it cannot, explain why or why not. Okay, so the first thing I need to do is check for continuity, right? It is a quadratic and it is continuous all along. So yes, it is continuous over this closed interval 1 comma 2. Differentiable, so let's find the derivative of over the open interval. So the derivative of this is 2x, right? And it's just a line, and it is differentiable over this open interval. So by definition, what do I have? F prime of c is equal to f of b minus f of a over b minus a. So my f of c is, either you can, I'm going to do 1 with c. So that's 2c equals f of b is what? F of b will be f of 2 minus f of 1 over 2 minus 1. So 2c f of 2 will be 9/2 minus 3/2 over 1. Oh, it's 2 minus 1, not 2 minus a. I will solve that. I get 6 over 2, which is 3, and c is equal to 3/2. And notice 3/2 does fall in, 3/2 is basically 1.5. It does fall in that interval of 1 and 2. So this was, what did we apply here? The mean value theorem, because of f of a was not equal to f of b, right? So I'm just going to say it was the mean value theorem that we applied. So because it's asking, the question is asking which can be determined, which can be applied. Number 2. So it's saying the same thing, right? So first we need to check for continuity over this interval. A sine graph is a very smooth curve, and it is continuous all along. So it is continuous over that interval from 0 to pi. Differentiable. So first find the derivative of sine 2x, which would be what? Cosine 2x times 2, which is also continuous. So it is differentiable over the whole thing, as cosine is also a very smooth curve, so it is differentiable over the open interval 0 comma pi. Okay, so here I can either check whether, in order for it to be mean value theorem, I can apply my mean value theorem right now, but in order for it to be Rolle's theorem, f of a has to be equal to f of b, right? So let's check f of a, which is f of 0. So f of 0 would be what? Sine of 0 is 0, and f of pi, which is what? Sine of 2 times pi, which is 2 pi, which is also 0. So they're both same, so we will be applying the rules. So the Rolle's theorem. If you again, theorem TG, if you still forget to do this part, you can literally set your derivative, which is f prime of c equals f of b minus f of a over b minus a. I already know this is equal to 0, so I can just rewrite it as 2 cosine 2 x equals 0. Solve for x. So I'm going to divide by 2, so I get cosine 2x equals 0. Where is cosine 0? It is 0 at pi over 2 and 3 pi over 2. I'm going to divide by 2, so x is equal to pi fourths and comma 3 pi over 4. So pi fourths and 3 pi fourths both lie in the interval of 0 comma pi, so we're good to go. Okay, so finish up the remaining lesson, and if you have any questions, please reach out. Good luck, guys.